What if everything you thought you knew about the vast emptiness above us was just the tip of an unimaginable cosmic nightmare? Space isn't the serene, twinkling expanse we see from Earth. It's a silent, merciless void filled with horrors beyond human comprehension. In this video, we'll uncover 20 terrifying facts about the universe that will haunt your thoughts long after you look up at the night sky again. From black holes that rip apart time itself to invisible forces dragging our galaxy toward an unseen doom, these revelations will make you question how fragile our existence truly is. Stay with us because by the end, you'll never see the stars the same way again. But before we go any deeper into the cosmic horrors lurking out there, let's start with the most immediate terror, the vacuum of space itself. Imagine stepping outside your spacecraft without a suit. In less than 15 seconds, you'd be dead in ways that defy every instinct of human survival. Your blood wouldn't just chill, it would literally boil away as the zero pressure outside vaporizes the fluids in your body. Your lungs, desperate to hold onto air, would collapse violently, tearing apart from the inside as the last oxygen is ripped from your throat. And if that weren't enough, the freezing cold of space would lock your body in an instant icy grave, all while your consciousness fades into blackness. This isn't just theory, it's happened. The Soyuz 11 crew in 1971 learned this the hardest way possible. Their capsule depressurized during re-entry, and though they landed safely, rescuers found all 3 astronauts lifeless, their bodies ravaged by the vacuum's cruel physics. Space doesn't hate us, it doesn't care enough to hate, it just kills without a second thought. And this is only the first horror on our list. Wait until you hear what comes next. Now let's turn our attention to something far more sinister: black holes, the universe's ultimate shredders. Picture this, you're drifting toward one, pulled in by its monstrous gravity. As you get closer, the forces at work become unbearable. The side of your body nearest to the black hole feels a pull so strong it stretches you like taffy, while the other side resists, compressing you inward. Scientists call this nightmare spaghettification, and it's as gruesome as it sounds. You wouldn't just die, you'd be torn apart atom by atom, stretched into a thin, screaming strand of matter before being swallowed whole. And here's the creepiest part: it happens in absolute silence. The event horizon, the point of no return, doesn't even whisper as you cross it. No sound, no warning, just the relentless pull of gravity so powerful that not even light can escape. That's right, a place where the fastest thing in the universe gets dragged down like it's nothing. Once you're inside, the laws of physics as we know them break down. Time distorts, space warps, and whatever's left of you becomes part of the black hole's infinite darkness. These cosmic monsters don't just kill, they erase. And the universe is littered with them. But while black holes are the universe's silent predators, there's another unseen horror lurking in the dark rogue planets. Imagine a world untethered from any star, drifting alone through the endless void. These cosmic orphans don't orbit a sun, they wander freely, invisible to telescopes, their icy surfaces reflecting no light. Some may have been flung from their home systems by violent collisions or gravitational chaos. Others might have formed in the cold depths of interstellar space, never knowing the warmth of a star. Now picture this: one of these frozen wanderers could be barreling toward our solar system right now, undetected. Without a star's glow to betray its approach, it might be just beyond Pluto before we even spot it. And here's the chilling part: some rogue planets could harbor alien life. Deep beneath their icy crusts, geothermal heat or radioactive decay might sustain vast subsurface oceans, just like Jupiter's moon Europa. Entire ecosystems could thrive in perpetual darkness, frozen in time until a chance collision cracks their icy shells open. But the real terror: a rogue planet's gravity could wreak havoc if it passed too close to us. It might fling asteroids into Earth's path, knock planets out of orbit, or even steal our own world away from the sun's warmth. dooming us to an eternal ice age. And the worst part, we might not see it coming until it's already rewriting the fate of our solar system. The universe is full of these silent drifters, and any one of them could be death disguised as darkness. Now, let's shift our gaze from the silent drifters of space to something far more violent and instantaneous: gamma-ray bursts. These are the universe's most powerful explosions, capable of unleashing more energy in a few seconds than our sun will produce in its entire lifetime. Picture a cosmic detonation so bright it outshines entire galaxies, but here's the catch: it could also erase life on Earth in the blink of an eye. Gamma-ray bursts occur when massive stars collapse into black holes or when neutron stars collide, sending jets of radiation screaming across space at nearly the speed of light. If one of these beams were pointed directly at us, the effects would be apocalyptic. The gamma rays would strip away Earth's ozone layer, exposing all life to deadly ultraviolet radiation. The sky would ignite in a searing flash, followed by a wave of destruction, crop failures, mass extinctions, and a planet left barren in milliseconds. And this isn't just science fiction. In 2004, a gamma ray burst 50,000 light-years away, briefly ionized Earth's upper atmosphere. It came from a magnetar in our own galaxy, a neutron star with a magnetic field 1 trillion times stronger than Earth's. If a similar burst happened even 10 times closer, it could trigger a global catastrophe. The terrifying truth: we'd have no warning. These bursts travel at light speed, meaning the first sign of danger would be the lethal radiation itself. So while rogue planets lurk in the shadows, gamma-ray bursts are the universe's sniper shots, silent, sudden, and utterly unstoppable. And the cosmos fires them at random with no regard for who or what might be in the crosshairs. But if you think gamma-ray bursts are the only cosmic threat looming over us, prepare for an even slower, more inevitable doom. Our own sun, the very source of life on Earth, will one day turn against us in a cataclysm written in the laws of physics. 5 billion years from now, the sun will exhaust its hydrogen fuel and begin its death throes, swelling into a monstrous red giant. As it expands, its outer layers will engulf Mercury and Venus, reducing them to molten slag. Earth won't escape unscathed. Our planet will first be baked by the sun's intensifying heat, boiling away oceans and scorching continents into lifeless rock. Then, depending on how much the sun expands, Earth might either be swallowed whole or left as a charred cinder orbiting a dying star. The timeline might sound comforting: 5 billion years is an unimaginable stretch of time, but the reality is chilling. Long before the sun's final act, its growing brightness will render Earth uninhabitable in just 1 billion years. The oceans will evaporate, the atmosphere will bleed into space, and any remaining life will face extinction. This isn't some distant sci-fi scenario. It's an unavoidable future, a reminder that even the most stable parts of our cosmic neighborhood are temporary. The sun's death is a slow-motion apocalypse, one that's already ticking away in the background of our daily lives. So while gamma-ray bursts are sudden and random, the sun's fate is a guaranteed horror story, written in stardust and waiting at the end of time. But the dangers of space aren't just about distant stellar explosions or the slow death of our sun. Right now, as you watch this, an invisible killer lurks in the void: radiation. Space is flooded with cosmic rays, high-energy particles that zip through the universe at nearly the speed of light. These aren't just harmless flashes of light. They're atomic bullets capable of tearing through the walls of a spacecraft like paper and shredding human DNA on impact. Imagine a single particle, smaller than an atom, slamming into your body with enough force to knock electrons loose from your cells. Over time, this damage adds up, increasing the risk of cancer, cataracts, and even brain damage for astronauts. And it's not just deep space that's deadly. Closer to Earth, there's an eerie zone called the South Atlantic Anomaly, where our planet's magnetic field dips unexpectedly. Here, radiation levels spike, forcing the International Space Station to shut down sensitive equipment as it passes through this cosmic minefield. Solar flares make things even worse. These explosive eruptions from the sun unleash waves of charged particles that can fry electronics and bathe astronauts in dangerous doses of radiation. In 1989, a flare knocked out power grids across Quebec, leaving millions in the dark. Now picture that same energy hitting an astronaut with no atmosphere to shield them. The terrifying truth: there's no perfect shield against space radiation. Even with advanced materials, prolonged exposure could turn a mission to Mars into a one-way trip for human health. Every second spent in space is a gamble with these invisible killers, a reminder that the universe doesn't just kill with black holes or dying stars. Sometimes the silent threats are the most horrifying. But if radiation makes space sound like a silent battleground, the fate of the universe itself is even more unsettling. Here's something that will shake your understanding of reality. The universe isn't just expanding, it's speeding up. Scientists call this mysterious force dark energy, and it's slowly ripping the cosmos apart. Picture this: every galaxy outside our local group is being dragged away from us faster and faster, like dots on an inflating balloon that's stretching beyond control. One day, those distant galaxies will vanish from view entirely, their light too faint to ever reach us again. This isn't just about losing a pretty night sky. The acceleration points toward a grim finale called heat death. Over trillions of years, as space stretches thinner and colder, stars will burn out, black holes will evaporate, and matter itself will disintegrate into isolated particles drifting endlessly in the dark. No new stars will form, no life will stir. The universe will become a vast, silent graveyard where even time loses meaning. The creepiest part: dark energy is winning. It makes up nearly 70% of the universe's energy, and we have no idea what it actually is. Some theories suggest it's woven into the fabric of space itself, growing stronger as the cosmos expands. Others hint it could be a sign of extra dimensions or even a glitch in our understanding of physics. One thing's certain: this invisible force is stronger than gravity, stronger than anything we know, and it's remaking the universe in a way that leaves no room for escape. So while black holes and gamma-ray bursts are terrifying in their own right, dark energy is the ultimate horror story, a slow, unstoppable erasure of everything written into the laws of reality itself. Now let's warp your sense of time literally. Imagine you have an identical twin, and one of you stays on Earth while the other blasts off into space at near light speed. When the astronaut twin returns, they'd be younger than their Earth-bound sibling. This isn't science fiction, it's Einstein's theory of relativity in action, and it's called time dilation. The faster you move through space, the slower time ticks for you compared to someone standing still. Here's where it gets eerie. If an astronaut spent years orbiting Earth at high speeds, they'd age slightly slower than everyone back home. Over decades or centuries, that gap could grow. Picture returning from a deep space mission only to find your children older than you or your hometown unrecognizable. Time dilation means space travelers might outlive their own families by mere seconds stretched into years. Even our daily tech relies on relativity. GPS satellites orbit fast enough that their onboard clocks tick slower than clocks on Earth. Without constant time corrections, your phone's navigation would be off by miles within minutes. So every time you use Google Maps, you're literally syncing with Einstein's ghost. The universe doesn't just bend space, it twists time like taffy, and we're all just along for the ride, which makes you wonder, if time is this fluid, what else about reality isn't as solid as it seems? Now, let's venture into something that might make you second-guess the next space rock you see. The idea that life could spread across the cosmos isn't just wild speculation, it's a real scientific theory called panspermia. Picture this: microscopic organisms, maybe even viruses, hitching a ride on asteroids, comets, or even our own spacecraft traveling between worlds. Here's the unsettling part. If alien microbes exist, they could be completely unlike anything on Earth. Our immune systems wouldn't recognize them, and there'd be no natural defenses. Remember the Andromeda strain? That fictional superbug wiped out a town in days. While that's sci-fi, the underlying fear isn't. In 2019, scientists found tardigrades, tiny, nearly indestructible creatures still alive on a crashed Israeli moon lander. If Earth's toughest hitchhikers can survive space, what else might be out there? And it's not just incoming threats. NASA sterilizes probes to avoid contaminating other worlds with our bacteria. But what if we're not careful enough? A single microbe could disrupt an entire alien ecosystem, or worse, bring something back. Imagine a Martian flu or a Europa plague, something evolution never prepared us for. Space isn't just empty and cold, it might be teeming with invisible stowaways, waiting for the right moment to land. Makes you wonder, are we the hunters in this cosmic game, or the hunted? Now here's something that might change how you look at the moon forever. It's not just hanging there, it's actually slipping away from us bit by bit. Every year, the moon moves 3.8 centimeters farther from Earth. That might sound tiny, but over millions of years, it adds up in a terrifying way. Think of the moon as Earth's silent stabilizer. Right now, its gravity keeps our planet's tilt steady at around 23.5 degrees, giving us predictable seasons. But as the moon drifts off, that tilt could start wobbling wildly. Picture this: one moment the poles freeze over entirely, the next they're as warm as the equator. We're talking about climate chaos on an unimaginable scale, oceans shifting, storms raging, entire ecosystems collapsing. And here's the real kicker: without the moon's pull, Earth's rotation would speed up too. Days would get shorter, winds would grow fiercer, and the very rhythm of life would be thrown off. Some scientists even argue that without the moon's influence, complex life might never have evolved in the first place. So while it'll take hundreds of millions of years to happen, the moon's slow farewell isn't just a cosmic curiosity, it's a countdown to a radically different Earth. Makes you wonder, is our planet's calm just a temporary gift from its celestial neighbor? But now, let's turn our attention to something even more unfathomable lurking out there in the cosmos. Meet the neutron star, nature's ultimate atomic nightmare. Imagine a single sugar cube that weighs as much as 1 billion tons. That's the mind-bending density of one of these cosmic horrors. Neutron stars are what's left after a massive star explodes in a supernova. All that remains gets crushed down into a ball just 12 miles across, yet so dense that a teaspoon of its material would outweigh Mount Everest. The gravity is so intense that atoms themselves collapse, protons and electrons fuse together into neutrons, creating a material unlike anything we know. And if the crushing weight wasn't terrifying enough, their magnetic fields defy belief. Picture Earth's magnetic field, the one that gently guides compass needles. Now multiply that by trillions. A neutron star's magnetic pull is so monstrous it could rip the electrons right off your atoms from light years away. These fields twist and snap with such violence that they create starquakes, cosmic tremors so powerful they send shockwaves through space-time. Here's the unsettling part: some neutron stars called magnetars are even stronger. If one of these got too close, its magnetic field would erase the data from every credit card on Earth. And every now and then, they unleash bursts of energy so bright they outshine entire galaxies for a fraction of a second. So while they might be tiny on the cosmic scale, neutron stars are proof that in space, the most terrifying things often come in the smallest and most deadly packages. Now, brace yourselves for a force so immense it's tugging our entire galaxy toward the unknown. Deep in the cosmic shadows, there's something called the Great Attractor, a gravitational monster so powerful it's pulling the Milky Way toward it at a staggering 14 million miles per hour. What makes this even more unsettling, we can't even see it clearly. This mysterious behemoth sits behind what astronomers call the zone of avoidance, a dense region of stars, gas, and dust near the center of our own galaxy that blocks our view. It's like trying to spot a hidden predator through a thick cosmic fog. Scientists estimate the Great Attractor's mass could be equivalent to tens of thousands of Milky Ways combined, bending the very fabric of space around it. Entire galaxy clusters are being dragged into its grasp, caught in an unstoppable current like leaves in a cosmic river. And here's the chilling part: we don't know exactly what it is. Some theories suggest it might be an unimaginably large concentration of dark matter. Others speculate it could be a supercluster of galaxies so dense it warps the universe around it. Whatever the truth, one thing is certain: it's pulling us in, and we're powerless to resist. So while we go about our daily lives unaware, our galaxy is on a one-way trip towards something lurking in the darkness. And the scariest part, we might never know what's waiting for us there. Now, let's turn our attention to a danger much closer to home, one we've created ourselves. Imagine a world where leaving Earth becomes impossible, not because of some cosmic horror, but because of our own clutter. This is the nightmare scenario known as Kessler syndrome, a chain reaction of collisions in space that could turn Earth's orbit into an impassable minefield. Right now, there are over 500,000 pieces of space debris hurtling around our planet at speeds exceeding 17,000 miles per hour. Even a fleck of paint at that velocity can punch through a satellite like a bullet. But here's where it gets terrifying. If just a few of these objects collide, the resulting debris could trigger more collisions, which then create even more debris. It's like a domino effect, but with catastrophic consequences. Scientists warn that if this cascade begins, low Earth orbit could become so congested with shrapnel that launching new satellites or even crewed missions would be too dangerous. Imagine a future where we're cut off from space entirely, stranded on Earth with no GPS, no weather forecasting, and no communication satellites. Our modern world would grind to a halt. Worse yet, cleaning up this mess is nearly impossible. Proposed solutions like giant nets or lasers to vaporize debris are still in their early stages. Meanwhile, the problem only grows as countries and corporations continue to launch more satellites into an already crowded sky. So while we gaze at the stars, dreaming of exploration, we might be sealing our own fate closer to home. The final frontier could become a prison of our own making, locked behind a barrier of spinning metal and shattered dreams, and the clock is ticking. But now, picture something even stranger lurking in the cosmic shadows: white holes. If black holes are the universe's ultimate traps, sucking in everything that crosses their path, white holes might be their bizarre opposites. Imagine a cosmic fire hose violently spitting out matter and energy with no warning. Unlike their dark counterparts, white holes refuse to let anything in, only out. The idea alone bends the mind. Where does all that material come from? Some theories suggest white holes could be the other end of black holes, spewing out what their twins devoured. Others propose they're remnants of the Big Bang itself, ancient relics still erupting with primordial energy. But here's the unsettling part: we've never actually seen one. White holes remain purely theoretical, hidden somewhere between math equations and cosmic mystery. And if they do exist, their behavior defies everything we know. A white hole could erupt without warning, hurling asteroids, radiation, or even stranger things into space. What if one suddenly appeared near Earth? Could it shower our solar system with debris from another time, another universe? Or worse, what if it's something we can't even comprehend? White holes remind us that the universe holds puzzles even our boldest theories can't solve. They might be cosmic exits, portals, or glitches in reality itself. Until we find one, if we ever do, they'll remain one of space's most haunting what-ifs. A reminder that out there, the rules we know might not apply at all. But now, let's venture into one of space's most baffling emptinesses, the Boötes void. Picture a region of the universe so vast and empty, it defies comprehension. Spanning an unimaginable 330 million light-years, this cosmic desert is nearly devoid of galaxies, a staggering void in the fabric of space itself. Most of the universe is dotted with galaxies clustered together like cities in the night sky. But the Boötes void, it's more like a ghost town, an eerie, almost unnatural expanse of nothingness. Scientists estimate there should be around 2,000 galaxies in this space. Instead, they've found fewer than 60. Where did everything go? Some theories suggest the void could be evidence of alien megastructures, vast constructions that have absorbed all nearby matter. Others propose it's a glitch in reality itself, a cosmic error where the rules of physics simply didn't apply. Could it be a scar from an ancient collision with another universe? Or perhaps a region where dark energy has completely taken over, pushing galaxies apart with unstoppable force. What makes the Boötes void even more unsettling is its sheer scale. If you placed our Milky Way at its center, we'd be utterly alone, surrounded by darkness for millions of light years in every direction. No neighboring galaxies, no cosmic landmarks, just an endless, silent void. Is it a natural phenomenon or something far stranger? Either way, the Boötes void stands as one of the universe's most chilling mysteries, a reminder that even in the vastness of space, true emptiness can be the most terrifying thing of all. And as we peer deeper into the cosmos, we're left wondering what other voids might be lurking out there, waiting to be discovered. But while the Boötes void leaves us staring into cosmic emptiness, there's another space phenomenon that could hit uncomfortably close to home: solar storms. These eruptions from the sun's surface aren't just dazzling light shows, they're potential civilization killers. Take the Carrington event of 1859. A massive solar flare erupted, sending a wave of charged particles straight at Earth. Back then, it fried telegraph systems, sparking fires, shocking operators, and causing auroras so bright they made people think the sun was rising at midnight. But here's the terrifying part. If that happened today, our hyper-connected world would face a catastrophe. Modern power grids, satellites, and internet infrastructure are far more vulnerable. A storm of that magnitude could induce currents strong enough to melt transformers, crippling electricity for months or even years. Imagine hospitals without power, water treatment plants failing, and global communication networks collapsing. Supermarkets would run empty as supply chains grind to a halt. Even your phone, useless without satellites or cell towers. Scientists warn we're overdue for another Carrington-level event. In 2012, a flare just as powerful narrowly missed Earth. Had it hit, the damage could have cost trillions, and with the sun's activity increasing toward its next peak around 2025, the risk keeps growing. The scariest part, we'd have barely any warning. From the moment a flare erupts, we'd have less than a day before the particle storm arrives. Governments and power companies are working on safeguards, but no system is fully prepared. So the next time you see headlines about solar activity, pay attention, because our star holds the power to send us back to the dark ages in a literal flash. But just when you thought the universe couldn't get any stranger, there's something far more elusive pulling the strings: dark matter. This invisible force doesn't just exist, it dominates the cosmos, making up roughly 85% of all matter in the universe. Yet we can't see it, touch it, or even detect it directly. It's like a ghostly puppeteer bending galaxies to its will without ever revealing itself. Here's how we know it's there. Stars on the outer edges of galaxies rotate at speeds that defy the laws of physics unless some unseen mass is holding them in place. Without dark matter's gravitational grip, entire galaxies would fling themselves apart. But what exactly is it? Scientists have hunted for clues for decades, from underground labs to deep space telescopes, and still it slips through our fingers. Some theories suggest it's made of undiscovered particles, while others propose it could be a shadowy gateway to parallel universes, warping reality in ways we can't yet comprehend. The creepiest part: dark matter doesn't just shape the cosmos, it might decide its fate. If dark energy, its even more mysterious counterpart, keeps accelerating the universe's expansion, dark matter could be the last remnant holding galaxies together before everything tears apart. So while we go about our lives completely unaware, this invisible force is silently weaving the fabric of existence. And if that doesn't make you question what else is out there, just wait. The universe has even darker surprises in store. Now let's turn our gaze to one of the most unsettling questions in all of science. Where is everyone? This is the heart of the Fermi paradox, the haunting silence of the cosmos despite the overwhelming odds that alien civilizations should exist. With billions of stars in our galaxy alone, many hosting Earth-like planets, the universe should be teeming with life. So why haven't we found a single trace? The answers are far from comforting. One terrifying possibility is the Great Filter, a cosmic bottleneck that prevents civilizations from advancing too far. Think of it like a gauntlet of doom, where any species that reaches a certain level of technological progress inevitably meets its end, the chilling part. We don't know if we've already passed this filter, maybe life is rare, or if it's still ahead of us, lurking in our future like a ticking time bomb. Consider this. If the Great Filter lies ahead, it could mean every advanced civilization hits a wall, whether through nuclear war, runaway artificial intelligence, or environmental collapse. We might be racing toward our own destruction without even realizing it. Or worse, we might already be alone. The silence of the universe could mean we're the first, the last, or worse, the only ones who ever made it this far. And the deeper you dig, the darker it gets. Some theories suggest that advanced civilizations might choose to hide, avoiding contact to stay safe from something even more sinister out there. Others propose that the universe itself is rigged, with forces we can't yet comprehend wiping out intelligence before it spreads. So the next time you look up at the stars and wonder why they're so quiet, remember, their silence might be the loudest warning of all. But what if the universe itself is sitting on a knife's edge, just one quantum hiccup away from total annihilation? Brace yourself, because false vacuum decay is perhaps the most existentially terrifying disaster lurking in the cosmos. Here's how it works. Picture the universe as a vast, fragile bubble, one that's currently resting in a state called a false vacuum. It's stable for now, but not truly stable. Think of it like a marble balanced on the edge of a hill. It could stay there for billions of years, but one tiny nudge, say a random quantum fluctuation, could send it tumbling down into a lower energy state. Now imagine that marble is reality itself. If even one tiny point in space were to collapse into this true vacuum, it would unleash an unstoppable wave of destruction. A sphere of pure annihilation would expand outward at the speed of light, rewriting the laws of physics as it goes. One moment, stars and planets exist, the next, they're erased without a trace, replaced by something entirely alien. And by the time you saw it coming, it would already be too late. The worst part, this isn't science fiction. False vacuum decay is a real, albeit speculative, consequence of quantum field theory. There's no warning, no defense, and no way to predict when or if it might happen. It could be set off tomorrow by a random particle collision in deep space, and we'd never even see it coming. So the next time you look up at the stars, remember reality as we know it is balanced on a razor's edge, and the universe might just be one quantum sneeze away from total oblivion. And speaking of things that defy reality, let's tackle one last question. What if everything we see, everything we are, isn't real at all? But what if the knife's edge we're balancing on isn't real at all? Here's something that will make you question everything: the unsettling idea that our entire universe might just be an advanced simulation. Think about it like this. If humanity keeps improving technology, one day we might create hyper-realistic virtual worlds indistinguishable from reality. Now flip that. What if some other civilization has already done it and we're the ones inside their experiment? This is the simulation hypothesis, and it's not as far-fetched as it sounds. Prominent scientists and philosophers, from Neil deGrasse Tyson to Elon Musk, have seriously debated its possibility. Then there are the glitches, those weird moments when reality seems to stutter. Ever heard of the Mandela effect, where large groups of people remember events completely differently? Some recall Nelson Mandela dying in prison in the 80s, despite him living until 2013. Others swear the Berenstain Bears were once spelled Berenstein. Could these be coding errors in our simulated universe? But here's the real nightmare fuel. If we are just lines of code in some higher being's computer, what's stopping them from shutting us down? Imagine the creators of this simulation hitting delete out of boredom or to free up processing power. 1 second, we're here, the next, absolute nothingness. No warning, no explanation, just gone. Whether it's quantum physics or eerie coincidences, the evidence or lack of it keeps the debate alive. So the next time your Wi-Fi cuts out or déjà vu hits, ask yourself, is this just life or is someone pressing reset? Now that we've journeyed through these 20 cosmic horrors, let's take a moment to reflect on just how fragile and mysterious our place in the universe really is. As we wrap up this journey through the darkest corners of the cosmos, let's take one final look at the sheer terror lurking beyond our tiny blue planet. From the vacuum of space tearing bodies apart to black holes spaghettifying everything in their path, the universe is anything but friendly. Rogue planets drift unseen, gamma-ray bursts could erase us in an instant, and the sun's eventual death will turn Earth to ash. Even time itself bends in ways that defy logic, while dark matter and the Great Attractor pull strings we can't see. And then there's the chilling possibility: what if none of this is real? What if we're just lines of code in some unfathomable simulation, one keystroke away from vanishing forever? The universe doesn't just ignore us, it's indifferent in ways that should keep you up at night. But here's the thing, that terror is also what makes space so fascinating. Every one of these nightmares is a reminder of how small we truly are and how much we still don't know. So tell me, after hearing all this, what sends shivers down your spine? The silent pull of a black hole, the thought of an alien virus hitching a ride on a meteor, or the eerie silence of the Fermi paradox screaming that we might be utterly alone? Drop your answer in the comments below if you dare, and don't forget to like, subscribe, and hit that notification bell, because the cosmos has plenty more horrors to uncover. Until next time, keep looking up and maybe sleep with the lights on.